Okay, I'm going to start my today's session and I'm going to continue my discussion on chi-square test. This is the note which I actually explained in my previous class, which this is a brief glimpse of what I discussed in the previous session. Yesterday, I told you to go through my video that was uploaded in YouTube. If you have gone through the video, you will be able to understand what I'm presenting right now. So this is the example which I discussed over here. And I also explained that this is the test statistic and it is the ratio of the square of the deviation of the observations to the expected observation. And also I told that if the test statistic is greater than the tabulated value of chi-square, we reject H naught, otherwise we accept H naught. The blood cancer type problem, the blood group and cancer, stomach cancer related problem was explained. And we came to the conclusion that this is the calculated value of chi-square. And this value was taken from the table, which I shared with you in my in the Google Classroom. And we see that at 5% level of significance, the tabulated value of chi-square at 3 degrees of freedom is 7.815, which is greater than the calculated value. The calculated value is lesser than this, and we actually accept the null hypothesis at 5% level of significance. And also I discussed that the chi-square statistic follows chi-square distribution with n-1 degrees of freedom, where n is the sample size. The above test that I explained in my previous session, that means this is the test statistic I'm talking about. And the process that I applied over there is actually falls into the category of chi-square test of goodness of fit. So this test has a specific name, which is called chi-square test of goodness of fit. And here in problem number 2, I have again set one example, which first of all, I'm going to explain manually, and then I'm going to show how to use a mathematical software to find the chi-square statistic. So this particular problem is also an example of a chi-square test of goodness of fit. A random sample of 100 students has been taken into consideration, and the observed frequencies are respectively given as follows. Okay, so if you add these numbers, you will get the value 100. All these frequencies have been taken from some sort of observation, and therefore these frequencies are observed frequencies. Question is, we want to test the hypothesis that absence of the students is equally likely to occur on any of the 5 days. These are the absentees, or number of days the students were absent, or the number of absentees on a particular day. Okay, so on Monday, 27 people were absent, and on Tuesday, 19 people were absent, and on Friday, 26 people were absent, and so on. This is an observation corresponding to a single week. So we want to test whether this observation corresponds to the fact that the absence are equally likely to occur in any of these 5 days. 5 days. So here, since observed frequencies are given, we want to find out the expected frequency, just as we did in the previous example, and we want to test the goodness of fit by using the chi-square statistic. First of all, it is given in the problem that whether this absence is equally likely or not. So for which I am considering the probabilities of these 5 days, since these 5 days are actually the exhaustive number of days, and they are mutually exclusive, so and they are also equally likely. So we have assumed in null hypothesis that this absence of students is equally likely distributed over the 5 days, And we have set the null hypothesis by considering the probabilities for each I to be 1 by 5. Against the alternative hypothesis that the absence is not equally likely. And we have considered here pi not equals to 1 by 5. If pi is not equal to 1 by 5 for at least one I, then the absence will not be equally likely. So these are my null and alternative hypothesis. The observed frequencies, just as before, I'm denoting the observed frequencies by capital Ni. So from the chart, we can tabulate all the observed frequencies as follows. N1 is 27, N2 is 19, N3 is 13, N4 is 15, N6 is 26. All these values are given. The expected frequency, as you know, in this goodness of fit test, the number of persons gives you the number of observations. 100 students were there. So 100 is the number of observation. And since the probabilities are, the specific value of these probabilities are 1 by 5. So for each of I equals to 1 to up to 5, we can consider the values, the individual values of each of the probabilities, capital P1, capital P2, and capital P5 to be 1 by 5 each. And therefore, the expected frequency will be determined by the mean of the binomial random variable, which is given to be n into P. So expected frequency for the ith day is n into Pi, which is 100 into 1 by 5, which is 20, and 20 will be same for each and every day. For Monday, the expected frequency is 20. For Tuesday, the expected frequency is 20. For Friday, the expected frequency is 20. And you see that observed frequencies are somewhat varies from these expected frequencies. Sometimes it is larger than the expected frequency. Sometimes it is smaller than the expected frequency. And if you keep on taking the observation, it may be sometimes exactly equal to the observed frequency. So when this happen, when this type of variation happen, what we take the sum of the, we take the deviations. But if I consider the deviations as a whole, the total deviation is always 0. You know, the sum of the deviations are never considered. Instead, what we consider is the sum of the squares of the deviations. So now under the null hypothesis, we have this particular formula. So what we have done, from each of these observed frequencies, the corresponding expected frequency have been subtracted and taken, a square has been taken. And we have considered the square of the sum deviation, its ratio to the expected frequency has been considered. So for the first observation, it is 27 minus 20 whole square by 20, and so on. Since 5 observations are given, chi-square statistic comes out to be 8 after calculating all this. Since there are 5 observations, so according to the theory, the degree of freedom is equal to 4, because we know that this particular formula follows chi-square distribution with n-1 degree of freedom. So we have to check the tabulated value of chi-square from the chart that I have provided you, and the tabulated value of chi-square comes out to be, let's see how much the value comes out. If I go to the chart and if I go to the chi-square table, at 5% level of significance at 4 degrees of freedom, the chi-square value comes out to be, this is 5% level of significance. This is the area under consideration, and this is the degree of freedom I am considering. So the value comes out to be 9.49. Okay, so let's see whether it is 9.49 or not. So you see that it is 9.488 and approximately, and therefore chi-square tabulated value of chi-square is larger than the calculated value of chi-square. And since the calculated value is lesser than the tabulated value, we fail to accept our, we fail to reject our null hypothesis, or in other words, we call that we accept our null hypothesis. And hence we can conclude that the absence of the students distributed over the 5 days in a week are equally likely. One important fact that provided you have noticed it, and if you have not noticed, then let me bring this to your uh, notice that this particular observed frequencies, if you take the total of these observed frequencies, the total comes out to be 100. So what you can say is that sum of the observed frequencies, the sum of the observed frequencies Ni is equal to 100. But also you observe that when we calculate this expected frequency, for each of the 5 days, the expected frequency is 20. So here also, the summation of the expected frequency is 100 because 5 into 20 is 100. So this is a condition in chi-square statistic, which is also very important, and you have to keep in mind that the sum of the observed frequencies must be equal to the sum of the expected frequencies. If in the examination, online examination, you may be asked, which one of the following conditions relates to chi-square statistic, and suppose you can find one of these condition is given to be this, then you are going to tick it. In the previous example also, probably you have noticed that the sum of the observed frequencies came out to be exactly equal to the sum of the expected frequency, and it is very fundamental condition in case of chi-square statistic. So we are done with our manual calculation. Now let me show you something. This same calculation with the help of a mathematical software. So I'm stopping this share. I'm going to present this particular note once again later on. So I hope you are able to see this presentation that is in front of you. This presentation, you already are familiar with this because in the last semester I showed this in one of my classes. I showed this presentation to you. And this is the mathematical software called Maple. Somehow I got this from somewhere. Anyways, that is not a matter issue. So using this mathematical software Maple, and you know that there are various other mathematical softwares available. So I'm going to see whether we can calculate the chi-square statistic or chi-square test, whether we can perform the chi-square test using this mathematical software or not. So how to look for this? How to find out whether chi-square test can be done or not? I do not know what is the codes that I need to use over here. So what we do, we go to the help section, we click on this, then this particular page opens. Here we write what we want. So we write chi-square test. Chi-square test, and then you have to search for it. See, here it is showing one of the test. It is and it is showing that it is called chi-square goodness of fit test. Probably this is my command that I want to use over here. So we will click on it. Once we click on it, the page explains us about the observed frequencies and the expected frequencies, a little bit about the knowledge of the chi-square goodness of fit test that I explained just now. Now, once you get this knowledge from here, what we need to do is that we have to consider this command. We have to copy this command from here, and we have to go back to this window and open a new document by clicking on it. I'm going to paste the command over here. Put a semicolon and then enter. Now your testing is activated. The entire testing is activated. Just like we did in case of linear algebra, we write with linear algebra and then we activate the command where under this umbrella we can perform various linear algebraic operations. Similar is the case with this one. Now you see, since we already have the knowledge, we consider these observed frequencies. They have given us a sample, so we will just copy it from here. Repeated application of this particular commands will help you to remember and not to go back again and again to see what were the comments. Now, these values are the sample values that they have used, but these are not my values. So what we need to do, we have to consider our values that is present in the problem. Now, if you have the, I'm presenting my screen, you can see very well. The observed frequencies are 27, 19, 13, 15, and 26. So let me give these values as input into the comment. So 27, 19, and 13. Okay, let me give the input. 27, 19, and 13. And the last two values are 15 and 26. Okay. 15 and 26. And if I put it, I have to finish my command by putting a semicolon over there. If I enter, the value has been read properly by the software. Now you have to consider the expected frequencies. The number of observed frequencies and number of expected frequencies have to be same. So we paste all the expected frequencies over here. And somehow in that particular problem, their expected frequency is also 20. And in my case, my expected frequencies are also 20. Only difference is in the number. They had 6 observations, I have 5 observations. So I have given the software the input of these expected frequencies. Once this is done, the command which will calculate the chi-square statistic of goodness of fit is this one. So people who use this mathematical software, they try to remember this command. Okay. If you cannot remember the command, no problem. Maple help is always there. It will help you to find out the command when it is required. Once I click this particular, once I write this command, I finish it by a semicolon and enter. And once I enter, now you just see what it is calculating. It is calculating this. It is writing that the null hypothesis is observed sample doesn't differ from the expected sample. That means they are equally likely. Alternative hypothesis is saying that observed sample differs from the expected sample. That means they are not equally likely. How many observations are there? Categories means observations. So 5 observations are there. What is the degree of freedom? Degree of freedom is 4. So chi-square statistics is being calculated at 4 degrees of freedom. What is the computed value of the chi-square? We got 8. They also got 8. They also calculated the p-value. A p-value, you know, it is the lowest level of significance at which null hypothesis would be rejected by treating the null hypothesis to be true, which is 0.09. So at any level of significance greater than 0.09, the null hypothesis will be rejected. Any level of significance lesser than the p-value, the null hypothesis will be accepted. Our level of significance is 0.05. So our null hypothesis has been accepted because it is lesser than 0.09. And the critical value is 9.48. Our critical value was 9.488 approximately, and the chart it was showing 9.489 like this. And the result is, the outcome of the experiment is that the null hypothesis has been accepted. So you see, by using this mathematical software, very well you can calculate the chi-square goodness of fit test. Okay, let us go back to the problem. Now I was sharing this particular note with you. So this particular note has been this particular calculation is actually telling with the result obtained by the Maple software. I have also pasted here the commands of the Maple software for your knowledge. So somehow, if you can get hold of the Maple software from somewhere, you can use this command to do the statistical calculations. Now, there are various softwares available. Nowadays, people use Python, people use R, people use uh, Mathematica, MATLAB. All these mathematical softwares are capable of doing the mathematical calculations, but it is not possible to know the commands of each and every software. Okay, so we become familiar with one of the softwares, we become comfortable with one of the softwares. So I had the Maple software with me. I used to do lots of linear algebraic calculations using the math or quantum computings with this Maple software, but I also wanted to know whether Maple can use, Maple can help us to do the statistical calculation or not. So I looked for it and I found, and then that's why I'm sharing this particular thing with you. So here are the commands, and here are the results that is telling with my manual calculation. And we have, using the mathematical software, we have come to the conclusion that all the days are not equally, all the observations are actually equally likely distributed throughout the week. Here is in problem 3, there is another example for you of similar type. I'm not going to explain this problem. It's whenever I'll share the note with you, you will try to do the problem by yourself. And I'm just skipping the things. And here I have made the note that in the above calculations, the thing that just now I had explained to you, that in the above calculations, one of the fundamental condition for applying the goodness of fit test is this, that the observed sum of the observed frequencies must be equal to the sum of the expected frequencies. Okay. Now to determine the p-value of the chi-square test, what we do is that we calculate the test statistic. If the test sorry, just a minute. We calculate the test statistic, and if the value of the test statistic is new, then we calculate the p-value with the help of the given formula. So if you want to do the manual calculation using the chart, this is the formula of calculating the p-value of the chi-square test. They have written that program 13.1, the image, this particular thing I have taken in the image from a particular book, and I have pasted it over here. This image, in this particular image, you can see that there is a statement written that program 13.1 can be used to determine both the value of the test statistic TS and the resulting p-value. Remember that this program they are talking about, and the image that I have collected from a book, this book is not talking about the Maple software. Rather, what they used in their case is the software called Minitab. So they are talking about the program written in Minitab, and they are referencing that program over here. Program 31 corresponds to the program 13.1 of Minitab, not of Maple. Maple, that which I have shown you just now, it's different. Some people can also show the same calculation using Mathematica. Some other people can show the same mathematical statistical calculation using R and so on. But since I'm not familiar with those softwares, therefore I'm using Maple over here. Anyways, let's come to the next topic, which is kind of generalization of what we have done just now. Right now, we are going to test the independence in population classified according to two characteristics. Okay, so this is another type of testing in chi-square. This is also falling under the category of goodness of fit test. So let us try to understand what it is telling us. Okay, with the help of an example. Consider a population. This is my example. Consider a population of voting age adults, and suppose that each adult is classified according to both gender, female or male, okay, and their political affiliation towards some political party. I have selected the problem from a book where the name of the parties were written to be Democratic, Republican, and Independence, but I have changed the name just to get a feel of the fact that we are not in America, we are in India, so we have to consider the name of the parties we are familiar with. So I have used the names, following names which are uh, in vogue right nowadays. It's BJP, Trinamool, and CPIM. The adults who are going to vote, they are politically affiliated to either of these three parties. Let capital X be the characteristic representing gender and Y be the characteristic representing political affiliation. So these are the two random variables. Since there are two possible genders and three possible political affiliations, so we consider the two variables R and S. R is taking the value 2 because there are two categories. One is female and male, and three political affiliations, that is BJP, Trinamool, and CPIM. Okay. So let us say that a person's X characteristic is 1 if the person is woman, and 2 if the person is a man. Also say the person's Y characteristic is 1 if the person is BJP, and 2 if the person is a Trinamool, and 3 if he or she is CPM. So these are the things that we are considering corresponding to the random variable capital X and capital Y. These are the meanings of the statements that have been made in the question. What we can do is that we can take a random sample of 300 people, and from these 300 people, by asking them, we can segregate the people into two categories. First of all the males are taken and put aside, all the females are taken and put at another side, and then by asking them individually, we can get the, if they tell the truth, okay, in that case we can get a glimpse of their affiliations towards a political party. And from this we have come to know that 68 people out of 300 is politically, and they are males. 68 males out of 300 are politically affiliated towards BJP. 32 males out of 300 are politically affiliated towards CPIM. Similarly, 72 females politically affiliated to Trinamool, and 52 of females out of 300 are politically affiliated to BJP, and so on. We have considered this as a chart. Chart reflects the correct, clearly what information we have obtained by collecting the random sample of 300 people. And row wise, if I see, this gives the total of 156, which counts the total males in the observation, and 144 gives the total females in the observation. I'm coming to the points given by capital N1, capital N2, M1, M2, M3. I'm coming to the meaning of this particular notations very shortly. And I have also written here this term which is called Nij. Capital N is the number of observation. Previously, that was unidirectional observation in the previous two problems. Here, the observations are bidirectional. So two subscripts have been used. And J, I have considered two variables, two subscripts I, which one of which I and J, one of which counts male and female, and another counts the political parties. This sort of table is called the 2x3 contingency table. Okay, and contingency table are often used in chi-square statistic, chi-square test. It is called 2x3 contingency table because the order of the matrix is 2 by 3. Now, in general, you can consider the contingency table of any order. It can be square also, it can be of a rectangular type also. What do you want to test? That is an important question. So we want to test the following. We will be interested in developing a test of the hypothesis that the X characteristic and Y characteristic of randomly chosen member of the population are independent. And we know that if two variables are independent, capital X and capital Y are independent, then probability of X intersection Y is equal to probability of X into probability of Y. So if independently capital X choose the value I and capital Y choose the value J, and if they are independent, then we can write this probability that X takes the value I and Y takes the value J. We can write this as probability of X equal to I into probability of Y equal to J. In short, by notation Pij and Pi and Pj, we can write it in the following manner. So according to this, we can design our null hypothesis as follows. So what we can write? We can write in the null hypothesis that yes, indeed, the observations are independent. So Pij equal to Pi into Pj are happening for all Ij. And in our alternative hypothesis, we are going to write that Pij and Pi is not equal to Pi and Pj. So observations are not independent. This is the generalized version of the chi-square statistic that we are going to use over here. Okay, so what we find is that summation over I and summation over j, nij minus eij whole square by eij. Double summation have been taken because this is a generalization of chi-square test of goodness of fit, which is bidirectional. What is probability of, what is expectation of EI? Expectation of VI, expectation EI is denoted by EIJ, and it is the quantity defined as small n multiplied by Pi and Pj. But we know that Pi individually is the ratio of the observed value capital Ni to the total value. Pj is the observed value capital Nj to the total value. Sorry, this would be not Nj, this will be Mj. It's a printing mistake. I will later rectify it. So this is Mj. It is better to use different notation. So if I substitute this Pi and Pj in the formula of Eij, then we will get n into Ni by n, Mj by n. And so Eij comes out to be Ni into Mj by n. Now we know from the chart that these bidirectional observations are as follows. N11 is equal to 68, N12 is 56, N13 is 32, N21. These are all the matrix elements that we are considering over here. So we have tabulated all the matrix elements in this particular case. I have activated the chat box so that you can put your attendance over there. Anyways, so all the observations have been taken and have been denoted by Nij as follows. And now we are going to calculate the expected observations, which is also bidirectional. So I have prepared a similar chart over here. And in this case, how to calculate this particular, how have I calculated this particular values? By using this particular formula. Eij is given to be Ni into Mj by n. Now you see, if I want to calculate Eij corresponding to this row, what I need to do is the following. This 68 is the value of N11. Now suppose I want to calculate E11. Using the formula that Eij is equal to Nimj by n, what I do is that we consider N1, we consider M1, we multiply N1 by M1, and we divide by n, which is 156 into 120 by 300. And that gives the tabulated value, which I'm going to show below. If I consider this one, this is the observation N23. So if I want to calculate E23, what I need to do is that we have to consider N2 and M3, and we have to divide by N. Now N2 is 144 and M3 is 52. We shall multiply the two and we will divide it by 300. In this manner, I have calculated all the probabilities. I have calculated all the probabilities here in this case. Now let me proceed further. So after calculating all the probabilities in this way, what I have done is this. I have tabulated the things again in a similar fashion over here. And it is also to be noted that just like the unidirectional case, here also in the bidirectional case, the double summation of observed frequencies is equal to the double summation of the expected frequency. That means the total observed frequency is equal to the total expected frequency. And then you can take the help of this, you can take this tedious job to calculate all the differences, taking their squares and putting their ratios and sum up all the things together, which I have skipped for the time being and have taken the help of the maple. Now here, this command that you can see is the, what sort of command is this? This command is actually the command of unidirection. Now, if I want to get the command of bidirection, what we need to show, get is another statistical chi-square statistic command. The current command will not work out over here, as you can see. So what we need to do is that we have to consider this independent test. See, similar type of thing has been written over here. They have explained the test, independent test, and they have shown it by an example. So let me find whether we can get a comment from here or not. I'm looking for the comment. Okay, so command is it there, comment? Okay, so let us try to find out from here. Chi-square independence of test. Okay, so this is your comment. So what I need to do is that I need to take the, I have to consider this command and have to paste it over here. Once again, put semicolon, and that will be activated with statistic. After this, what I need to do is that I have to consider these observed frequencies. These observed frequencies, we have to paste it over here. What are my observed frequencies? First of all, if I write like this is in the column form, but my matrix is in the row form. So we don't have to use this. We have to change this command a little bit. So I think we should continue in the next session, because this session is going to end. We have less than 1 minute time. So I am going to explain this particular command in the next session. Okay, just wait for it.